In this video, I'm going to show a way how to structure a Docker setup for a PHP project. This is basically the root of our application. Like our application for now only consists of one file, index.php, which will just echo out hello world. But it also contains a .docker folder. In this folder, there is all of our Docker setup defined. So first of all, we have a docker compose.yml file, and in there we define all the services that we need for our setup. So in our case, that is Nginx, PHP-FPM, and a Workspace. And those services are then defined in their respective subfolders of the Docker directory. So for example, take the Nginx service. It contains configuration files that are only relevant for Nginx, and it also contains a Docker file. Then we have a .shared folder, and in here we have configuration and scripts that are shared across multiple services. So for example, in the configuration folder, we might have PHP configuration that is relevant for PHP-FPM, but also for our Workspace, which is really just a PHP CLI container. And in our case, that is just a common opcache configuration. Under the scripts directory, we might have scripts that we use across multiple containers. So for example, a script to create a consistent user setup. The basic idea of that folder is to provide a way to avoid duplication. All right, so coming back to the Docker Compose YAML file, we also have variables in here, and those variables are defined by a .env file, an environment file. So usually you don't distribute a .env file directly with the repository, but instead you will provide a .env.example file that contains all the available variables, and the developer has then to copy this example file and name it to .env. And yeah, that is then what's being used to substitute the variables in the Docker Compose file. Since we usually don't operate from within this folder, but from the root folder of our application, running Docker commands is a little bit more complicated than you are probably used to. To simplify the usage, we provide a so-called Makefile. And in this file, we define a couple of so-called targets that we can then easily use to manage our Docker setup. So the next thing for me to do is run those 4 make commands to get started. So if I just type make, I get a list of all the available commands that I can run. The first thing that we run is docker clean. So we start out with make docker clean, and that will remove any currently existing .env file for now. Next thing to do is make docker init, and that will give me a fresh copy of the env.example file and place it under .env. The next thing to do is run make docker build from scratch. That will actually build all the containers, from scratch. Since this can take a couple of seconds, I would now take a look in the Makefile. Makefiles are organized in so-called targets, which are basically commands that you can run. We can provide a default command that is run when we simply type make. In our case, this is help. The contents of help is defined here. And this AWK magic is basically responsible for generating this self-documented Makefile. So it will parse the comments and will then give me this nicely formatted overview when I type make. I just mentioned that since we are running commands not from within the Docker folder, but from within the Docker PHP tutorial folder, things get a little bit more complicated. So let's make this clear. Usually when you're working with Docker, you would go in the directory where your Docker Compose file lives, and then you can simply write Docker Compose and then show me the current configuration. So that is something that you would usually do when working with Docker. Unfortunately, then running this from the application directory, so one level up, this won't work anymore because, well, we don't have in that directory, there's no docker compose.yaml file. So to make this work, we would have to specify where the compose file lives. So -f, and then it's in .docker compose.yaml, and we would also have to specify the project directory, because otherwise it won't find the corresponding end file. Our command now becomes this. So still works, but it's a lot more inconvenient to write that. Coming back to make, we can simplify that by just providing all of that information in a variable. We can then simply use that variable whenever we want to use Docker Compose throughout the Makefile. Let's start with the Nginx service. The Docker file itself, it starts with defining the base image of the container. So we just use the official Nginx latest base image. Like the first thing that we do is copy over all the shared scripts from the shared folder and make sure that they have executable rights. One important thing to mention here is that this only works because we specified the correct build context for this service or for this container in the Docker Compose file. In Docker Compose, under Nginx, I define the build context as the directory where the Docker Compose file lives. And that means that everything in here gets sent to the Docker daemon as build context, which in turn means that when we're building this container, this Nginx container, everything in the build context is now available to us. So that is something that I didn't know before, because I always thought that you had only everything that is in the same directory as the Docker file. But again, you can specify any build context you want, and by using everything in the Docker directory, we have access to like the shared configuration and the shared scripts. All right, so this is the first thing that we do. We copy over all the scripts so we can access those. Then we set some general system configuration. For example, the time zone, like it's just a very simple script that ensures that the time zone is set to, well, whatever I want it to be set. But I can reuse that across all containers that need it. So remembering this is much simpler than remembering like the contents of that file. And if I have a bug in here, if I want to change something, I have only one place where I need to change it, and not like once per container basically. After setting the time zone, we are going to make sure to have a consistent user setup. And that is something that is super important when working with Docker, because otherwise you might run into problems with your file permissions and folder permissions. So this script, create user, makes sure that the data user exists, and this is the important part, has a specific user ID. So the user ID 1000 in our case. Since those are variables, you could replace that when building the container. Usually this is not required if you are running Docker Desktop, so Docker for Windows or Docker for Mac, because they have some sort of virtualization layer in between that usually doesn't require this kind of thing. But if you're running Linux, then you would usually want to set the user and group to whatever you have on your host system so that your file permissions don't get messed up. And then we're going to install a common set of software. This is kind of my go-to set on software on debugging tools, or basically something that I want to have available in every container during development. This is something that is totally individual, so use in here whatever you think makes sense for you. This is just my set of go-to tools basically. Next thing we do is copy Nginx specific configuration in the container. You can see this service directory variable here that I defined at the top of the Docker file. Because we don't use like a build context that only contains the Nginx contents, I want to have a convenient way to specify how to access the contents of this folder. So I define like the path to get from the build context to the folder up here, and then I can just reuse it through the Docker file. So we copy over the Nginx configuration, then we are using a script called modify config to replace variables that are in the configuration that I just copied. Up here I defined variables, and like the double underscore is like no official convention or anything. I just like to use something that I can easily recognize as a variable in a file. We use this script, modify config. Let's have a look here, which is simply sed, and it will then look for the variable name, replace it by a value that I give it in a file that I provide. So in that case, we're taking the Nginx configuration and we are replacing the user and the group with whatever we have been specifying up here. So again, that everything is consistent. Next thing is that we do kind of the same thing with the default configuration for our site. Super usual Nginx configuration. We have variable for the root, so basically where Nginx looks for files. And we configured how Nginx handles PHP files. In that case, it will pass the request onto PHP-FPM to port 9000. That will work because when we use Docker Compose and we have a service called PHP-FPM, then any other container can reach that service by its service name, PHP-FPM, as long as they are on the same network, which is something that we ensured in the Docker Compose file by assigning all of the services to the backend network. We have now configured Nginx, then we set the working directory. So when we log into the container, we are in this directory, run a cleanup script. Also have a look at this. We'll, for example, clear the temp folder, which is where we copied over the scripts, the shared scripts. So those will be gone at the end of the container build, basically, because we don't need it anymore. Then we just set the command to Nginx. So this is what will be run when the container starts, and we expose port 80 and 443 for HTTP and HTTPS connections. So building has finished. And the next thing that I like to do is test if everything works. Let's take a look at the Makefile. There's a target called docker test. And if I run this, make docker test, it will, well, on a very high level, show me that everything is okay, quote unquote. So it's super not sophisticated. But for example, it will ensure that the PHP version in our Workspace container is actually PHP 7.3, for example. The script itself, dockertest.sh, is just like a series of bash functions that I then call down here. They just very simply check if things are in order, basically. And like this might seem unnecessary, but it becomes very valuable when you start to, for example, refactor your containers. Then having something like this that on a very high level tells you that everything is okay, that can save you a lot of time. So yeah, this is something that I really like. Like, it's far from the unit test that you know from PHP, for example, but it does the job and it saves time on refactoring. So yeah, that's cool. Remember that we have a Nginx and PHP-FPM service. So I would expect I can just open localhost in my browser and then see corresponding output. So in that case, I see hello world PHP, which is what we have seen in the index.php file a second ago. The next thing is checking if the Workspace container works as expected. So we can log into that container. Need to look that up real quick. So docker ps gives me the name of the workspace container, and then can log in. Docker exec ti name of container bash. So now I'm in the container. I'm already in the correct directory. I should have an index.php file in here. So I can run php index.php and I see hello world. Let's verify that it's actually connected to our host system. If I change the contents here, for example, I remove the exclamation mark, run the same thing in the workspace container, then the exclamation mark is gone. Same thing in the browser. I refresh and exclamation mark is gone. Let's go through the remaining services. First up, PHP-FPM. We start with using the official base image, and then we do the same thing as we just did in the Nginx container. So we copy the shared scripts, set the time zone, ensure the consistent user setup. We install the PHP extensions that we need for the service. Since we will need the same, or probably need the same extensions in FPM and in the workspace, it makes sense that this is also like a shared script. So this is the first reason why we would use a script to do that. The second reason is that some of the PHP extensions actually require additional software to be present on your system. I don't know, like a consistent way to figure out which extension needs which other software, but luckily there is a project that will do that for us. This is the project that I just mentioned. So somebody took the time to compile a list of all the PHP extensions, and we can simply download that script and then install the extensions that we need. So when we have a look at the site, then down here he lists all the extensions that are available together with the corresponding PHP versions. For now, we just use the opcache and the xdebug extension. Then install the same software as we just did for Nginx. Then we copy from the shared folder the PHP configuration, first thing. And second thing is copying PHP-FPM specific configuration. So in that case, for the PHP-FPM pool configuration, that is something that is only relevant for PHP-FPM. So having a look at the configuration file, then again here we define a user and a group that are used to run PHP-FPM, again to be consistent in the setup. And then we will use the same technique that we applied before in the Nginx service to replace the user with the actual user and the group. And then we do something interesting. We define our own entry point. So an entry point in a Docker file is basically the command that is run when your container starts. Sometimes it makes sense to put in your own entry point in between, so to speak, because you need to configure something that is only available at the runtime of the container. When the container is built and we go through this Docker file, that to me is something like the build time of the container. And when you actually start or run the container, then this is the runtime. We use that to resolve the IP address of the Docker host. So that is something that I explained in a previous video that we need in order to connect from PHP Storm from the host system to the container and be able to debug. The way we made this work in the last video is using a magic hostname called host docker internal that you can use to access the host system from within your Docker container. This works for Mac and for Windows when you're running Docker Desktop, but it won't work for Linux users because this variable is not available for Linux users. We work around that by checking if the host name exists. So this is true for Windows and for Mac, but if it doesn't exist, then we will get the IP address of the host and we'll put it in the etc hosts file. So this is basically our shim, our workaround for Linux users. And the important part in this script is the last line. So in here, we tell the script to take everything that we put in as arguments and execute it. And by that, we basically make the whole script a decorator around the actual entry point. Having a look at the Docker file, we call or we define the entry point by use our script to define the correct hostname and as argument pass in PHP-FPM. And our script will now do its thing, resolve the hostname, and then execute whatever comes afterwards. Let's move to the last service, the Workspace. First of all, exactly the same thing as for FPM. Like we use a different base image. We use the PHP CLI base image, not the FPM one, but up here exactly the same extensions, same software. One thing we need to do for this Workspace container is enable SSH. This is something that we do in this part. So we install OpenSSH server and then we provide a SSH key that we can use to log in and set the correct permissions for the SSH folder and the authorized keys file. And we need that to, again, enable debugging from within PHP Storm later on. Then we copy over the shared configuration. So again, same thing as in the FPM container. And we define the same entry point. Again, we want to be able to debug this container, so we need to make sure that the hostname is available, so that is what we do here. You might be like a little surprised that we're using or defining a CMD here. So we could, instead of having those two commands, we could simply copy all of that and move that behind our own script as an argument. That would have the same effect. So in your Docker file, if you have an entry point and a CMD instruction, then everything you have in here is just used as arguments for your entry point. I think I just copy pasted it from the example in the official Docker documentation. Again, would be the same thing if I just like take that and copy it over here. Since I just mentioned that like the Workspace is something that I want to be able to access via SSH, let's make sure that this is actually working. Log out of the container, clear the screen, SSH, we write a key file, so that is placed in Docker, in the Docker folder, Workspace, SSH, and then ID, insecure ID RSA. So in here is the key file defined. I log in as .data, that is the user that I specified. I want to log into localhost, port 2222. Now I'm in the Workspace container. One thing to note here, I used port 2222 because that is what I defined in my Docker compose file to bind to the port 22 on my container. Can log out again. If I run docker ps, you can see that I have a port mapping defined from like port 2222 to port 22 from my host system to the Workspace container. So that's why I put the 2222 up here. You might have noticed that by default we get this weird message of the day thingy up here when we log in via SSH. Let's say we wanted to change that and would now have to modify our container setup. We could simply take a look at the Workspace Docker file. To modify that exact thing, we would run echo and put this into etc message of the day, and that should effectively remove that message up here. So let's save this, and this is the nice thing about make. We already have a command to rebuild a container. Make docker build, and then I can specify the container and say, well, I want you to rebuild my Workspace container. And under the hood, it will run all the necessary commands to do that. Since I put that line at the very end of the Docker file, most of the layers are already cached. This is pretty fast. Only down here, after my echo etc message of the day configuration thingy, I will have to actually execute things. Log in via SSH. Yeah, the message is gone. I think this is it. So we talked about our application code. We talked about the .docker folder and how we structure that folder, how we define the services, that we use Docker Compose, that we use a shared folder for common configuration or shared configuration and shared scripts. Use a test file to make sure on a very high level that everything works as expected. We bundle everything up in a Makefile to make that basically the central entry point to our application. And Well, yeah, that is kind of it. And if you're done at the end of the day, you would simply run make docker down, and that would shut down all the containers. Or if you want to get started, you would run make docker up. This is simply your usual docker compose up -d basically.